All right, let's dive right in. If you're gearing up for the architect registration exam, you know that every single detail matters, especially when we're talking about fire safety. Today, we are going to master the fire extinguisher, breaking down exactly what you need to know for the PPD and PDD exams. Let's get to it.
You know, every single line you draw on a plan has safety implications. The ARE is designed to test your ability to make the right calls. Because, let's be honest, this isn't just about memorizing codes, right? It's about protecting actual lives.
So, this stuff? It's absolutely crucial for the PPD and PDS exams. So let's sharpen this part of your professional toolkit, and we're going to start with the absolute fundamentals of fire safety.
Okay, so before you can even think about choosing the right fire extinguisher, you've got to understand what you're up against. What kind of fire are we talking about? The NFPA, the National Fire Protection Association, classifies fires based on what's fueling them. Let's break them down.
First up, we've got Class A. These are by far the most common fires, the ones involving everyday stuff like wood, paper, and plastic. The absolute easiest way to remember this for your exam, A is for ash. If it burns and leaves an ash, it's a Class A fire. Simple as that.
All right, next up, Class B. Now we're talking flammable liquids and gases, things like gasoline or propane. And here's the critical thing you cannot forget. You can't use water on these fires. It will just spread the burning fuel everywhere. A great way to remember this one is B for the barrels these liquids often come in, or for the fact that they boil. Okay, Class C is a bit of a curveball. What's super interesting here is that it's not really about what is burning, it's about the situation. We're talking about a fire that involves energized electrical equipment. The huge danger here is the shock hazard. So, think C for current. In fact, if you manage to cut the power, it often just becomes a plain old Class A fire.
And finally, we have the really specialized one, Class D. These fires involve combustible metals, stuff you might find in an industrial plant or a high-tech lab. These are no joke. They're incredibly dangerous because they can react violently, even explode, with water or other common extinguishers. They need a very specific dry powder agent.
Okay, so we know the threats. Now let's talk about the tools. As the architect, you're the one specifying these things, and choosing the right extinguisher is a huge design and safety decision. So, at a high level, you can really think of extinguishers in two main camps. You've got your workhorse, that's the ABC dry chemical extinguisher you see pretty much everywhere, and then you've got your specialists. These are the precision tools for places where you just can't afford to make a mess.
So that ABC dry chemical, it's your jack of all trades. It's affordable, it's common, and it's effective on the three most common fire classes. But, and this is a big but, it leaves behind this fine, corrosive powder that will absolutely destroy electronics. So for the ARE, think of this as your default choice for a typical office space, but be very careful where else you specify it.
All right, let's talk about carbon dioxide, or CO2 extinguishers. These are fantastic for Class B and C fires, mainly because they are clean. They leave zero residue behind. But there are some major trade-offs. They're pretty useless on Class A fires, and here's the big safety warning. In a small, unventilated room like a server closet, they can actually displace so much oxygen that they become a real asphyxiation risk to the user. Now, for the places where you have truly irreplaceable stuff, we're talking data centers, museums with priceless art, or critical hospital control rooms, you're going to specify a clean agent like Halitron. It's clean, it's safe for electronics, and it's much safer for people than CO2. The only real downside? The price tag. But when you're protecting mission-critical assets, that cost is pretty easy to justify. Okay, so we know what the fires are, and we know what the tools are. Now let's talk about where to put them. This section right here, this is pure ARE gold. Placement, codes, and accessibility. You'll want to pay close attention. Okay, get ready to write this down. Here's a number you just have to memorize, 75 feet. According to NFPA 10, 75 feet is the absolute maximum distance a person should have to travel to get to a Class A fire extinguisher. And for those more dangerous Class B hazards, it's even shorter, just 50 feet. This is one of those numbers that just loves to show up on the exam.
And here's magic number 2, 48 inches. The Americans with Disabilities Act, the ADA, is super clear on this. The handle, the part you actually use, can be no higher than 48 inches from the finished floor. Why? So someone in a wheelchair can actually reach and operate it. And just a pro tip, if it's in a recessed cabinet, that height actually drops.
But wait, The ADA has more to say. To make sure it's not a hazard itself, an extinguisher can't stick out more than 4 inches into a hallway. You also have to design for a clear 30 by 48-inch floor space in front of it for access. And look at this detail, even the handle is specified. It can't require tight grasping or twisting. Yep, these are all totally fair game for an exam question.
So you probably won't be tested on how to actually use an extinguisher, but knowing the pass method, that's pull, aim, squeeze, sweep, is still really good context. It just reinforces why all those placement and accessibility rules you're designing for are so incredibly important.
Phew! Okay, that was a lot of info. So let's pull it all together into one place. Think of this next part as your ultimate cheat sheet for exam day.
First up, let's talk about money, because you know that's a huge part of the PPD exam. It's pretty obvious from this chart, right? There's a massive price jump from your standard ABC extinguisher to those specialized clean agents. Your job as the architect is to know when to justify that higher cost by identifying the specific, high-value assets that need that extra protection.
And here it is, the whole thing on one slide. This is your master chart. Seriously, pause here if you need to and just soak this in. See how it all connects? You start with the fuel type on the left, and it leads you all the way to a real-world application on the right. For example, look at Class C, a server room. You could use an ABC extinguisher, but you'd fry the servers, and that is why you specify a non-conductive agent like CO2 or a clean agent. This kind of integrated thinking is exactly what the ARE is looking for.
So, what's the big takeaway here? Understanding these systems goes way beyond just passing a test. It's about your fundamental responsibility to protect the health, safety, and welfare of the public. That's the whole point. So keep that in mind as you're studying. You've got this. Good luck.